In a previous video, we took a look at how the XC6 panel could be used as a dumb panel connecting to your server application, which could be a piece of software running on a computer, or it could also be another hardware broadcast device. The dumb panel device core, the Unisketch TCP client, means that our panel will connect to your server without knowing whether we start or stop recording or switch a source in a video router or similar. That's decided on the server. So it's just offering itself as a panel which can send triggers like button presses, encoder pulses, absolute positions of a T-bar. In return, it can retrieve a color and display content. And in that video, we also saw the XC6 panel blinking and flashing display content as you see right here. Now, in this video, I would like to demonstrate how you can take any of our panels and connect to your Unisketch TCP client compliant server application. And already I brought in some other units here. We have a rack unit. We have two remotes. We call these remotes because they are sort of handheld, or they can be clamp mounted on a tripod, for instance. We have the XC series, which is a modular concept. That's pretty exciting too. So the XC3 with a joystick edition, which is called XC7. And we have micros. The micro is very task-centric controllers like this one. You press a button, there are basically two buttons, two smart switches on it, and that's it. So, and I also brought a Gpio device over here. So we have 8 inputs, 8 outputs in this small device. They can all run the Unisketch TCP client, so they can work as dumb devices up against your software application. And the C20 already blinks along. Now, the funny thing is, if you look in the terminal that I have, where currently I'm running the color cycle display script here, you see how we already accept connections from two different clients. So this one would have one of the IP addresses, and the XC6 has the other one, and they are just being served by the same server in this case. So that's another way you can say the dumb panels are in fact sort of smart and intelligent, because they will allow you to connect multiple devices, of course, to the same server application, and that's thanks to IP, of course, which is unlimited in that regard. Now, what I want to do is to disconnect this guy and just set it aside for a moment, and then we'll bring in the C20 here. So you can see on the C20 we essentially have the same blinky thing going on with the display content updated and so on. But what we haven't seen so far is what happens in terms of triggers if we run a different script here. You can see as I press the buttons, we get the button pushes, the button presses gets into the terminal. We see how, as we discussed in the previous video, that any of the hardware interface components send the down command and then the up command and so forth, and we respond to that by changing the color. We can also see, and that would be a new thing, if I turn the encoder here, you see we receive pulses from the encoder. And if I go the other way, I receive a -1. And if I use the other encoder, you see just the HVC number changes to 9 instead of 10. So there we basically see how encoders is another interface component, which we didn't see on the XC6, but that's present on the C20 here. So that's a new thing. Let's try another one. Oh, by the way, it's connected by PoE. That's a pretty neat feature too. Now, while we are in the genre of remotes, let's try this one. This remote is called C15. It's also PoE powered, as you can see. And it has a joystick. It also has 2 smart switches. And you can see now in the server application here, we see again we are receiving button presses, and we see also how the colors are cycling, exactly as expected. We'll see the same for the smart switches. And now let's take a look at the joystick. So this is a thumb joystick. It's not extremely precise anything, but you see how we are just speed values in one direction, and if we go up, it's HWC6 that receives the speed value. So the center position is essentially 0, and when we go up to 500. If we go down to 500, and so forth. We can even push it on top, and that's HWC7 that works as a button. So there you have another example of a intelligent, smart, but dumb panel, in a sense. Now here we have one of the micros. It's called Micro Smart V, and the V is for vertical. We have a model which is better held like this, but this one fits nice into a hand, for instance. So again, with this one, we have the smart switches, which are not so much fun if we don't see any content in them. So let's just start another script here on the server. So now we can see the blinky action on the smart switches. Yeah, I'm kind of repeating myself by saying that it's the same concept seen over and over again. And that's essentially it. Now, there's something special about the Gpio, which we'll get to in a moment, but let's just take a look at the rack unit here, which is, I would say, a typical application of dumb panels, where you see them mounted in OB vans and in control rooms in various ways. So the form factor is fairly handy. And we are aiming at pushing out a new series of rack units, which are specifically targeted at dumb panel usage, where you'll see the very popular smart switches in these models. Now, this one is still a really nice and also a fairly friendly price-wise panel. We have 10 buttons with individual dedicated displays. Then we have a group of utility buttons here, and then of course 2 encoders. And again, you see in the terminal window, you can see how we receive encoder pulses and of course button presses as we press these buttons down. So nothing new there, it's just a rack unit. So again, it proves how our panels are really versatile. And again, just feel free to look in our catalog and you'll find a lot of different models that you can engage with. Now, the Gpio is special in the sense that obviously there are no buttons that can be colored. There are basically only triggers going in and also a response coming back. Now, the way it works is when you map the inputs and the outputs to the instead of buttons, then when you turn a button on, that would correspond to turning a relay on or flipping a relay so that it shorts the output, and likewise the input would work as a button down. And you'll see that when I apply power to it. And I brought a little test device, which is a plug with some LEDs on. And when I put them in here, it gives me a chance to see the status of the outputs as we are now working with this device. So let's try to plug it in. And this time I'll go to another script. And so the way I set this up, you can now observe in the terminal. You can observe how when I hold this one down, so I basically short an input. You see it works just as if it was a button press. And your application, your server application, can pick this up. On the other side, you can also see, if you look at the device itself, you see that just disregard these LEDs over here, but you see that, and maybe you can even hear it. You can hear a relay flipping. I can hear it, which is the reason why these LEDs light up as I short the inputs just next to. And then you may ask, how come that this happens this way? And that's a matter of configuration, because there would be no reason why these inputs over here in the one side are linked up with the other ones. But just for the sake of example, let's take a look at how the configuration for this device is. Now, to do that, I would need, so in a sense you can say I have deviated a little bit from letting this just be a dumb panel. I have set it up in a way so that we direct how these things work. So okay, let's now open the configuration page, and then you'll see how the configuration of this device is that for the output 1, 2, 3, and 4, we have mapped them to HWC numbers 1, 2, 3, and 4. But if we look at the inputs 5, 6, 7, and 8, I have mapped them also to HWC 1, 2, 3, and 4. And it's reflected in the terminal. So again, as you can see, I'm shorting this input. It's in the terminal, it says that HWC number 1 is held down, and when I release it, up again. And that's the reason why you experience that the relays are flipping on the first 4 outputs as I short inputs 5 to 8. Let's then finally take a look at the remaining controller. So we'll just put this aside, and you can keep in mind that we also do Gpio with all our interesting Gpio devices. And then finally, let's take a look at this one, the XC3, which is a nice modular controller. Now, for the fun of it, let's just break this module off, which is the joystick module, and we set up the rest like this. Okay, so we see the panel is booting up like any of the other panels. It has also announced itself already, and because we are not running the blinky thing, which I'll just do now, then now we see everything is beginning to blink again, just like we expected. Now, we do have a new component here. We actually do have the T-bar. So let's just look in the terminal. As I'm pulling the T-bar handle, you see values are transported from 0 to 1000 as I'm pulling the handle. Yes. And then, of course, we have the encoder knobs. We also can press buttons, etc. There's basically nothing new in that. Now, the new thing is that we have the modular control on the table this time. And if you don't know about the modularity, you'll be pretty amazed about what is about to happen now. And yeah, so basically, take a look at what happens when I now snap the module on. If you look in the terminal, you'll see how the terminal responds by recognizing that suddenly we have 8 new hardware interface components on this module attached to the main unit. And you see how they are beginning to blink and everything. Since this is a joystick, you would expect to see speed values communicated as I'm now pulling the joystick. The lagging you see is because the automatic routine that is updating all the blinking and displays runs in the background and interrupts, which is why you sometimes see the values lagging, but the speed is pretty good if we are not letting that interrupt happen. You can also rotate the top. So as I rotate this, you see we adjust speed in one direction and in another direction. And all the time it's the HWC number that determines this thing. You can even press the button on top. And if I detach the module, immediately the server will be told that we have now lost the contact to the numbers that you see here. The mapping indicates the mapping between what is called internal and external, or client and server HWC numbers, a fairly technical thing. But you can read about that in the manual. Actually, there was one last thing that I did, just because I thought that would be fun. And that requires me to change to a different script, which is playing a little bit with the joystick. So we take the joystick example here, and it's written specifically for this controller. So with this example, I basically update the display here with information about the position of the joystick. So you can see how quickly we can receive commands on the server side from the movement of the joystick and then communicate them back to the panel. It's very, very fluent, as you can see in this example.